In the quiet yet thunderous world of rocket engineering, something monumental is preparing to launch again. SpaceX, the pioneering company behind some of the most ambitious space dreams, is on the verge of its 9th test flight for the largest and most powerful rocket system ever created, Starship, paired with its enormous Super Heavy booster. Towering at nearly 400 feet when fully stacked, this rocket is almost as tall as the Great Pyramid of Giza. And according to Elon Musk, the man behind this cosmic venture, we might be seeing this massive machine soar into the sky once again as early as next week. His announcement, made casually yet confidently on X, formerly known as Twitter, came as a response to a SpaceX update stating that the Starship had just completed its static fire engine testing and was now going through the final touches before launch. The Starship program hasn't exactly had a smooth ride. Test flights in January and March ended in dramatic explosions, scattering debris and even interfering with nearby air travel. It wasn't just a show for space fans. The FAA had to issue warnings to aircraft in the area about falling parts from the malfunctioning rockets. In fact, these fiery failures triggered a full FAA investigation, which led to the rocket being grounded. But interestingly, even before the investigation into Flight 7 was completed, the FAA gave the green light to proceed with Flight 8, which eventually saw its investigation concluded on March 28. That tells us something big. SpaceX is not only learning fast, it's moving fast, and even federal agencies are starting to keep pace with Musk's rapid iteration approach. As of now, SpaceX hasn't revealed the exact mission goals for Flight 9, but the space community is buzzing with educated guesses. One of the most daring objectives could be another attempt to catch the Super Heavy booster midair using what SpaceX affectionately calls chopsticks, a pair of giant steel arms mounted on the launch tower. Yes, they're literally trying to catch a 230-foot rocket booster as it falls back from space, and yes, they've succeeded before. The first successful catch happened in October, and subsequent launches, Flight 7 and 8, also managed to repeat that astonishing feat. This maneuver isn't just about showmanship, it's about reusability. If they can reliably catch and reuse these boosters, it will drastically cut the cost of getting things into space, a cornerstone of Musk's dream of making humanity multiplanetary. But there's more at stake with each test flight. Another potential test on Flight 9 could include an on-orbit engine relight. That may sound technical, but it's essentially a test to see if Starship can reignite its engines while it's still in space. This capability is absolutely crucial for upcoming missions, especially the one that everyone is watching, Artemis 3. That mission, led by NASA, aims to return astronauts to the Moon, and Starship will play a major role as the Human Landing System, HLS. For Starship to serve this function, it has to refuel in orbit, which means docking with a propellant depot in space and restarting its engines to head toward the Moon. Successfully relighting the engines in orbit isn't optional, it's a requirement. And this year, SpaceX also plans to demonstrate how exactly they'll move that much propellant into orbit. NASA estimates it will take 16 flights to fill up a depot. Elon Musk, being the ever-optimist, thinks they can do it in just 8. So far, Starship has shown promise. On Flight 6, the spacecraft achieved an on-orbit engine relight for the first time, marking a huge step forward in this complex ballet of technology. That same flight also tested out something called catch-enabling configurations. Basically, they modified certain parts of the heat shield on the Starship's upper stage to make room for future hardware that could help with catching the stage, much like how they're trying to catch the booster. Every flight tells SpaceX more about how to make both stages of this rocket reusable. And full reusability is the holy grail here. If they can get both the booster and the Starship vehicle back, refurbish them quickly and send them up again, the economics of space change entirely. That's not science fiction, that's the goal. As for where all this magic is happening, most of it centers around a place called Starbase. This is SpaceX's private launch facility located in Boca Chica, Texas. Recently, the FAA approved an environmental assessment that allows SpaceX to increase the number of annual launches from this site, from just 5 a year to 25. That's a huge jump and signals just how aggressively SpaceX plans to scale its operations. If everything goes according to plan, the sky over South Texas is going to be busy. But it doesn't stop there. SpaceX is also building launch infrastructure at the Kennedy Space Center in Florida. This is the same historic site where NASA launched the Apollo missions, and where SpaceX already launches its smaller Falcon 9 rockets. However, launching Starship from there would require another detailed environmental impact statement from the FAA. Why the rush? Why is SpaceX pushing so hard to get more launches in the pipeline? It all comes down to the timeline. NASA's Artemis 3 mission, which will use Starship HLS to land astronauts on the Moon, is scheduled for no earlier than mid-2027. That might seem like a long way off, but in rocket terms it's practically tomorrow. And before a crewed flight can even be considered, SpaceX needs to complete an uncrewed lunar landing test by 2025. That gives them just about 2 years to prove that Starship can safely and reliably fulfill all of NASA's requirements. That's why each test flight is so important. It's not just a test, it's a rehearsal for the real thing, and time is running short. The pressure isn't just coming from NASA either. SpaceX has its own internal goals that are just as ambitious. Musk has repeatedly stated that he wants Starship to eventually make interplanetary travel possible. The moon is just a stepping stone. Mars is the real target. And to get there, SpaceX needs to master a number of complex technologies: orbital refueling, rapid reusability, in-space engine relights, and high-frequency launches. Every successful Starship flight gets us one step closer to those dreams. But with each launch comes risk, and that's where the challenge lies. Can SpaceX move fast enough to meet NASA's deadlines while maintaining the safety and reliability standards required for human spaceflight? The next few months will be crucial. If Flight 9 is successful, if the booster is caught by the chopsticks, if the Starship performs a flawless re-entry and splashdown, and if the engines can relight in space, it will be a massive boost in confidence for everyone involved. SpaceX needs these wins. Not just to prove the technology works, but to show that the entire system is maturing. Reusability is a central theme, but it's also about consistency. A rocket that works once isn't good enough. It has to work every time. And SpaceX knows that better than anyone. That's why each detail is being tested so thoroughly: every heat shield tile, every sensor, every landing algorithm. They're building not just for the next launch, but for the next decade of human space exploration. And make no mistake, the world is watching. From engineers and scientists to space fans and policymakers, everyone has their eyes on Starship. It's more than just a rocket, it's a symbol of what's possible when ambition meets engineering. And if SpaceX pulls it off, it won't just be a win for them or for NASA. It will be a win for humanity's journey into the stars. With Flight 9 just around the corner, the anticipation is growing. For SpaceX, each test isn't just a milestone, it's a data goldmine. Every launch gives engineers hundreds of variables to analyze, from engine behavior and structural loads to heat shield performance and aerodynamic stability. In the case of Starship, testing goes beyond simple launch and landing. It involves seeing how the vehicle performs during the entire flight profile, including critical stages like max Q, stage separation, booster return, upper stage orbit insertion, and re-entry. Each of these stages presents unique challenges that SpaceX must overcome if Starship is ever to carry people beyond Earth. Max Q is one of the most dangerous moments in any rocket flight. It's the point at which aerodynamic stress on the vehicle is at its highest. If a rocket is going to break apart due to structural weakness, Max Q is when it would happen. SpaceX uses each flight to fine-tune how Starship handles this intense moment. They're constantly modifying structural elements, software controls, and flight trajectories to better manage stress loads. It's a high-stakes experiment in real time, where even the smallest improvement can mean the difference between success and failure. Then comes the stage separation. For most rockets, this is a critical yet relatively straightforward process. But for Starship and Super Heavy, it's a complex dance. The timing has to be perfect. The booster has to shut down and move out of the way, while the Starship upper stage lights its engines and continues into space. Any delay, misfire, or incorrect movement could lead to a catastrophic failure. That's why SpaceX is constantly testing and improving this moment, tweaking their hot staging process, where the upper stage ignites its engines before fully separating from the booster to minimize energy loss. After separation, the focus shifts to the Super Heavy booster. This behemoth doesn't just fall into the ocean like most other first stages. Instead, SpaceX is working to recover it using the chopsticks mounted on the launch tower. These huge mechanical arms are designed to catch the falling booster mid-air, slow it down, and gently set it back on the launch mount. This process is revolutionary. No other rocket company has attempted anything like it. If it works consistently, it will change spaceflight economics forever. But getting it right takes practice, and each flight is one more opportunity to test this incredible recovery system. While the booster attempts its return, the Starship upper stage continues its journey into orbit. Once there, it must demonstrate stability, engine control, and the ability to maneuver. But perhaps most importantly, it must show it can relight its engines while floating in the vacuum of space. This is not an easy task. Igniting engines in space requires precise control of propellant flow, pressurization systems, and thermal management. Even a minor hiccup can cause the engine to misfire or fail completely. And when you're dealing with human-rated missions to the moon, there's no room for error. That's why this test is so critical. Another vital component is Starship's heat shield. Re-entry into Earth's atmosphere generates temperatures exceeding 1,600 degrees Celsius, which can destroy unprotected spacecraft. Starship is equipped with thousands of hexagonal heat shield tiles designed to absorb and deflect this heat. But not all tests go as planned. In previous flights, some tiles broke off during ascent or re-entry, exposing sensitive areas of the vehicle. SpaceX is now using each mission to test new tile materials, better adhesive bonding methods, and improved attachment techniques. They've even experimented with intentionally removing tiles to test catch-friendly hardware setups, thinking ahead to future reusability upgrades. As it descends, Starship must slow itself using both atmospheric drag and engine thrust. The vehicle's unique belly flop maneuver, where it falls sideways to maximize drag, is one of the most iconic elements of its design. At just the right moment, it flips vertically and fires its engines to make a controlled landing. This flip maneuver is incredibly complex. The timing, orientation, and thrust all have to work in perfect harmony. If even one variable is off, the vehicle could crash. But when it works, it's a masterpiece of engineering, a ballet of steel, fire, and gravity-defying precision. A successful splashdown or landing marks the final step of the test. If Starship returns to Earth in one piece, engineers can examine the condition of the heat shield, engine components, avionics, and structure. They can then recycle and refurbish the vehicle for future flights. This is the ultimate goal, creating a fully reusable rocket system that works like an airliner, flying regularly with minimal maintenance. It's a dream that could lower the cost of space access by 100-fold. And if SpaceX can achieve it, the entire aerospace industry will be forced to follow or risk falling behind. But building and flying Starship isn't just about engineering, it's also about logistics and infrastructure. SpaceX has built a massive production and launch complex at Starbase in Texas, which includes vehicle assembly facilities, test stands, control centers, and of course, the launch tower with its towering chopsticks. This site was once a quiet patch of land near the Gulf of Mexico, but it's now one of the busiest and most advanced rocket factories on Earth. The team there works around the clock, building, testing, and flying new hardware in a relentless pursuit of progress. To support more frequent flights, SpaceX has pushed for regulatory changes. The FAA's recent environmental review now allows up to 25 launches per year from Starbase, up from just 5. That's a 5-fold increase in launch cadence, showing just how serious SpaceX is about ramping up operations. And they're not stopping there. Construction is underway at NASA's Kennedy Space Center in Florida, where SpaceX plans to launch Starship from the historic pads once used by the Apollo program. Launching from Florida brings strategic advantages. It's closer to the equator, which helps rockets gain extra speed, and it's better equipped to handle high-frequency missions. Yet all of this is building toward one massive goal: sending humans to the moon. Starship has already been selected by NASA as the human landing system for the Artemis 3 mission, which will land astronauts on the lunar surface for the first time in over 50 years. But before that happens, Starship must prove itself through an uncrewed landing test planned for 2025. That gives SpaceX less than 2 years to perfect a system that has so far only completed a handful of partial test flights. The pressure is intense. Lives will be on the line. Every weld, every bolt, every line of code must work flawlessly. Beyond the moon lies Mars. Elon Musk's ultimate goal is to build a self-sustaining city on the red planet. Starship is designed from the ground up for this purpose. Its enormous payload capacity, reusability, and in-orbit refueling capabilities are all key elements of interplanetary travel. But to make that vision a reality, the company must master Starship at Earth first. That's why the test flights happening now are so vital. They aren't just steps toward another moon landing, they're laying the foundation for humanity's expansion into the solar system. If Starship works, Mars becomes a reachable destination, not just a science fiction dream. And let's not forget the commercial implications. Starship could revolutionize satellite deployment, cargo delivery, space tourism, and even point-to-point travel on Earth. Imagine boarding a rocket in New York and landing in Tokyo in under an hour. That's not just a fantasy, it's a real possibility that SpaceX is actively exploring. The rocket's enormous payload bay could launch entire space stations, lunar habitats, or interplanetary cargo missions. It could deploy giant telescopes, mine asteroids, or serve as a high-speed transport system for military or humanitarian missions. The potential applications are vast and transformative. Still, nothing is guaranteed. The path ahead is filled with challenges. Technical setbacks, regulatory delays, funding issues, and safety concerns could all slow progress. But if any company has shown an ability to tackle the impossible, it's SpaceX. They've already transformed spaceflight with Falcon 9, becoming the go-to launch provider for NASA, commercial operators, and international clients. And now, with Starship, they're attempting something no one has ever done, creating a rocket that can lift 150 tons to orbit, refuel in space, land on another world, and do it all again. As we await Flight 9, it's worth remembering how far we've come. Just a few years ago, Starship was a collection of renderings and mock-ups. Now, it's a real flying machine, testing hardware, flying into space, collecting data, and improving with each launch. The progress has been staggering even if it sometimes feels chaotic. That's Musk style: build fast, break things, learn quickly, and keep pushing forward. It's not traditional, but it's working. And as long as SpaceX keeps launching, testing, and improving, the dream of reaching the moon, Mars, and beyond remains very much alive. Flight 9 is more than just a test. It's a glimpse into the future. A future where rockets are as reusable as airplanes. Where space is open not just to astronauts but to scientists, explorers, and eventually everyday people. A future where we don't just visit the moon, we build on it. A future where Mars is not a mystery but a destination. And it all starts here with a giant steel rocket, a team of relentless engineers, and a belief that the impossible is just the beginning. So when Starship finally lights its engines again and begins its fiery ascent toward the stars, know that you're not just watching another launch. You're witnessing history being written, one flight